Today we're going to be talking about special segments in triangles. So yesterday we talked about when we had angles formed by tangents and chords and secants and all that stuff. Today we're going to be talking about what's the relationship between the segment lengths in the circle. Okay, our chord product theorem. So, our chord product theorem. EA times EB is equal to EC times ED. So basically, where they intersect, EA times EB is equal to the same thing as EC times ED. So, solving our first example for x. So, my intersection is there. So, one piece of that 8 times the other piece, x, is equal to 9 times 12. And 9 times 12 is 108. X ends up equaling 13.5. The next example, and I'm going to do it kind of up here over to the left of the example because I might run out of room. X times x plus 10 is equal to one piece, x plus 4, times by the other piece, x plus 2. So x squared plus 10x is equal to, when I multiply all that out, x squared plus 6x plus 8. Luckily, I subtract, and those x squareds cancel. They're not always going to cancel, people. We're going to have to do some factoring. I subtract these 6 over, and I get a 4x equals 8, and x equals 2. I don't know why that was so complicated for me. Okay. Next example. Biologists often examine organisms under microscopes. The circle represents field of view under the microscope with a diameter of 2 millimeters. So my diameter, the whole thing, is 2 millimeters. Determine the length of the organism, which we're going to call that guy x, if it is located 25 millimeters from the bottom of the field of view. So this is also x. Okay, so I have one piece, x times x, is going to equal one piece, 0.25, times by, the whole thing is 2 millimeters, this whole length. So that leaves just this part to be 1.75. We subtracted. So I have x squared equals, and again, this would be calculator work because even I am looking at my notes. And I remember when I did this problem in my notes, it was a pretty long decimal. So 0.6 millimeters. Remember, we square root to get rid of that squared. Okay, secant product theorem. Okay. EA, the outside part, times by the whole segment, EB, is equal to EC, the part outside, times by the whole segment, ED. Okay, secant product theorem. Solving for x here. So always remember, part outside is EH. H, 8, times by the whole segment. The whole segment isn't x, it's x plus 8. Is equal to the piece outside, 10, times by the whole segment, 10 plus 24, that's 34. So I have 8 times x plus 8 is equal to 340. Let's work smarter, not harder here. Divide by that 8. Those 8s cancel. And so that gets me 42.5, and I subtract to get 34.5. Tangent secant product. Okay, so last one we had 2 secants. And remember, it was part outside times the whole thing. Part outside times the whole thing, that's just AE squared. So if you remember, outside times the whole thing equals outside times the whole thing, you're not going to go wrong on any of these. Okay, next one. Okay, part outside times the whole thing, so that's 12 squared, is equal to the part outside the circle, which is x, times by the whole segment length. Well, that's 2x plus 2, because I have x plus a 2x plus 2. Okay, so now solving this. 144 is equal to 2x squared plus 2x. I distribute the x through. Any quadratic, you have to get it equal to 0 to solve it. And then we first try factoring. First factor out a GCF. Now we factor x squared plus x minus 72. Remember, I need 2 things that multiply to be a negative 72, but are going to add to be a positive x. So I have a minus 8 and a plus 9. And then set each one of those factors that has an x in it equal to 0. Now let's think about our possible answers here. X equals negative 9. If x equaled negative 9, this circle wouldn't exist because you can't have a negative segment length. So you always have to plug back into both of these to make sure you have possible segment lengths. So x equals 8 is my only answer. Okay, our next example. Again, one that's just a little bit more complicated. I need to find NL, so I want to make sure I find that. So I have the part outside, 6 times by the whole segment, which is 10, equals the piece outside, x plus 2, times by the whole segment, 3x plus 3. So I have 60 equals, I FOIL this through, I get a 3x squared. 6, 7, 8, 9 plus a 6. I get that equal to 0. I factor out any GCF that I have. And factor it out correctly. And then I try and factor this polynomial. 2 things that multiply to be a negative 18, we're going to add to be a positive 3. Multiplying to be a negative 18, adding to be a positive 3. Plus 6 minus 3. I set each one of those factors equal to 0. So again, if I plug in negative 6 into x plus 2, I would have a negative segment length. So that's not an answer. So x equals 3, but be careful. I'm glad I looked at this. I need to find NL. So that's that whole segment length. Okay, so that whole segment length is not what you have here. NL is the segment length of 3x plus 3. So NL, if I plug in 3, I get 12. And that is our video on special segments in circles. And really what you want to take away from this, if it's outside, piece outside times the whole thing. Piece outside times the whole thing. Okay, just remember that. Thank you for watching.